Welcome to topic number 20 in Richard James Mathematics Resources, and this one is entitled Mensuration. I am presently the Cape 2 teacher at Cornwall College, but I am quite familiar with the details of the topics that are being taught in the lower school, being of course the official typist of the mathematics department. As a matter of fact, I am quite familiar with the curriculum at the GSET level. I am saying this to say that I am aware that most of what will be presented in this topic should be revision for most students. The greater portion of the material should have been covered by all students who have finished grade 9. However, the requirements of the CSEC examination does not begin and end with merely finding perimeter, area, and volume of figures. Sometimes trigonometry and algebra are incorporated in the problems. This is because, as I always say, life is like that. We do not encounter ideal or clear-cut situations at any single time along the road of life. Therefore, students are required to use their imagination along with the knowledge that they have acquired in the other topics when answering examination questions that are based on mensuration. The prefix peri means around. This can be seen in words like periphery, pericarp, and periscope. The perimeter of whatever figure being discussed is the measurement around it. And the first one we are going to be looking at is the rectangle. A rectangle has 4 sides, of which opposite sides are equal. The longer sides are usually referred to as the length, L, and the shorter side are called the width, W. To find its perimeter, simply add all the sides. So we have that first side, which is the length, then the width, and of course another representation of the length and another representation of the width. So we have a simple algebraic expression right here which says that the perimeter is equal to the length plus the width plus the length plus the width. Simplifying that, we have the length occurring twice and the width occurring twice, so we have 2L plus 2W, and of course we can factorize the 2 is a common factor, so 2 times all of L plus W. Find the perimeter of each of the following rectangles. So perimeter is equal to 2 times all of length plus width, so length plus width in bracket, so the length is 5, the width is 3, and they will replace the lengths and the width in the formula. Of course 5 plus 3 is 8, and 2 times 8 is 16. The perimeter is 16 centimeters. And let us take another one. The same formula, 2 times all of L plus W, and we know the length is 12 and the width is 8, so 2 times 12 times 2 times 8, or 2 times all of 8 plus 12, and that is 2 times 20, and 2 times 20 is equal to 40 centimeters. Now we are going to be looking at regular shapes. What is a regular shape? Regular shapes have all sides equal. To find the perimeter of a regular shaped figure, we multiply the length of one side by the number of sides. So there we have a regular pentagon, meaning that all sides are equal. There are 5 sides, so we are going to say the perimeter is 5 multiplied by 7, and that is equal to 35 centimeters. Equilateral triangle. The equilateral triangle, 3 equal sides, so 3 multiplied by 9, and that is equal to 27. A square is a regular quadrilateral. All sides are equal, 4 of them. So the perimeter is 4 times the length of each side, and the length of one side is 6. So 4 times 6, we have the perimeter is 24 centimeters. Circles. The perimeter of a circle is called its circumference. The circumference of a circle is given by C is equal to 2 pi r, or C is equal to pi d. For information on radius and diameter, see topic number 19. That gives the definition and explanation of radius and diameter and everything that has anything to do with a circle. R is the radius of the circle. D is the diameter. Of course, the formula is given in this instance if we are talking about the radius of the circle, and of course in the other case if we are talking about the diameter of the circle. And this is the common Greek letter pi, and it is 22 over 7 approximately, and if we want to express that in decimals, we have 3.14. So of course we have the radius of the circle right there. So C is equal to 2 pi r. We're going to use the formula that has radius. 2 times pi times r, and that is what we're going to have now. 2 times pi, and the radius is 3.5. So of course we are going to simplify that. We don't have to, but we are going to simplify that. 3.5 times 2 is equal to 7. So we have this 2 to multiply by the 3.5, that will be 7. So we are going to use 7 to replace these two. So we have 22 over 7 multiplied by 7. And of course the 7's will cancel, and the answer is 22 centimeters. In this particular case, the circle that we have there, it is the diameter that is given. So C is equal to pi d. So C is equal to 22 over 7, and the diameter of that circle is 14 centimeters. So 14 divided by 7 is equal to 2. So we're going to divide this. 7 into 14 is 2. So we have what? 22 multiplied by 2. 7 into 14 is 2. That is how it is simplified. And we get the answer to be 44 centimeters. Here's another one. Of course, the radius is given, so we're going to use C is equal to 2 pi r. Whenever the diameter is given, we can conveniently say C is equal to pi d, which is the circumference. However, we may want to stick to only one formula and just use the radius. When we get the diameter, we divide that by 2 to get the radius of the circle. So instead of always using one or the other, some students prefer to stick to one. So if you prefer to just stick to radius, when you get the diameter, divide that by 2 and you'll get the radius. 2 pi r, 2 times pi times r. Any simplification, of course. We know that 10.5 multiplied by 2 is 21. So this 10.5 multiplied by the 2 that we have over here is 21. And of course 7 into 21 is going to give 3. So this multiplied by this is 21. So we have 22 over 7 times 21. And of course 7 into 21 is 3. So we have 7 into 21 is 3. So we are going to have 3 times 22, or 22 times 3. Multiplication is commutative. So we'll have C is 66 centimeters. We're going to be looking at the length of an arc. That is a portion of the circumference of a circle. An arc is a fraction of the circumference of a circle. If we can find the fraction of the circumference that the arc represents, then we can find its length. So the angle associated with one revolution is 360 degrees. So if you go all the way around, what is that angle? 360 degrees. Let us say that the angle that subtends the arc is theta. So we have an arc right there in red, and the angle that subtends that arc is theta. So the fraction of the circumference that the arc represents is given by theta over 360. We know the formula for the circumference of a circle. What? C is equal to 2 pi r. That's it. So the length of the arc is therefore given by the fraction of the circumference represented by the arc multiplied by the circumference of the circle. So what do we have? The fraction that represents the portion of the circumference that the arc represents, and that is multiplied by the circumference of the circle. In this particular case, we are using 2 pi r, and it's the same thing that we have right here. The exception is that we are using the formula when the diameter is included. So find the length of the arc that subtends the specified angle. So r is the radius of the circle, d is the diameter of the circle, pi is 22 over 7. So we have just having that information supplied to us on the slide so that we are just reminded. So in the first case, the length of the arc is the fraction represented by the arc multiplied by the circumference of the circle multiplied by the circumference of the circle. So we have the angle over 360. This is the angle that we have over 360 times 2 times pi times r. So we may take an approach in which we multiply all of the numbers in the numerator and all of those in the denominator. As we progress through the slide, we are just going to be looking at method of simplification of the fractions that we have here, or just to multiply or divide or both. But we are going to try to see if we can be systematic about it, so that when students get these problems, they can take similar approaches. So is either we are going to multiply all the numerators, multiply all the denominator, like that. So we're going to have 6 times 2 times 22 times 35. And then we're going to have 360 times 7. Dividing the numerator by the denominator, and that is the result that we have. Do not forget that whole numbers are treated like fractions whose denominators are equal to 1. So where we have 2, this is a fraction whose denominator is 1. The whole numbers are therefore multiplied in the numerator. So if this is 2 over 1, the numerator is 2 and the denominator is 1. So when we are multiplying the numerators, the 2 will be multiplied and 3.5 will also be multiplied. So we have another one. As a matter of fact, we have the same one, same problem, and what do we say? The numbers may be less cumbersome if we realize that 60 degrees is 1/6 of 360 degrees, or we may simply reduce the fraction. So instead of multiplying all the numerators and multiplying all the denominators, we might take an approach where we use simplification of fractions in order that the numbers that we have will be smaller. So of course we know that 60 will go into 360 6 times, and we can have that simplified quite easily right there. So notice in this case how much smaller these numbers are. Dividing the numerator by the denominator gives the same thing. It may not always be convenient to reduce a fraction that involves the angles. That is, this one. It might not be always convenient to reduce this one. Do not take a dogmatic approach to solving the problem. In mathematics, it is always wise to choose a method with a first step that simplifies the process if possible. So we are going to always, you can't just be one-track minded. You cannot just think a single way because it was done by your teacher or by Richard James Mathematics Resources. Always choose, according to the circumstance that you have, a method that gets the fraction or the set of numbers that you have right there simpler and quickly as possible. In this case, no value is given for the angle. This is because it is taken for granted that students know that only a right angle, that is a 90 degrees angle, is marked with perpendicular lines. Of course, we have the perpendicular lines here, so we are sure that that angle is 90 degrees. So what do we have? Of course, we have the diameter, so we're going to use pi d for our circumference. And of course, the angle over 360 has a fraction that is represented by the length of the arc that we are trying to find. Right. Advantage may be taken of the fact that 90 degrees is a quarter of 360 degrees, or we may reduce the fraction as usual. Either one simplifies the problem to the same extent. So that is a quarter. And of course, we say 308 to be divided by 28, and divide the numerator by denominator gives 11. And of course, what do we have here? All we do, multiply these numbers. These will represent the numbers in the numerator. And of course, we multiplied these numbers, and those will represent the number in the denominator. And as we said before, it may not always be convenient to reduce a fraction that involves the angles. Do not take a dogmatic approach to solving the problem. In mathematics, it is always wise to choose a method with a first step that simplifies the process, if possible. So we are looking at arc length again, and of course, notice the angle that we have there, 140 degrees. So angle over 360 times 2 times pi times r. Of course, the radius is given in this case, so we are going to be using 2 pi r for the circumference of the circle. In this case, the fraction created by the angles may be reduced to 7/8. Although it is very good being a reduction, we will reduce the entire fraction differently. This is to show that you may take any approach that is convenient to you. There is no restriction as long as we use a mathematically legitimate method in arriving at our answer. Reduce by 10 and then by 7. So let us see what that means. Of course, reducing by 10 may cause us to just strike zeros off, a 0 in the numerator and a 0 in the denominator, and then we are going to go through by 7. What do we get? Okay, so let us see how this works out. 7 into 14 is 2 that we have right there. The 36 remains, and of course we have our 22 repeated here and our 10.5. So in this particular case, 7 into 14 is 2, and that is what we have there. So we have 924 when we have multiplied all the numbers in the numerator, and then we are going to divide by 36, and what do we get? 25.67 centimeters. The reduction of the fraction was not by any means complete. Candidates may reduce the fraction completely, giving a very simple problem in the end, or as much as it takes to prevent the products of the denominator and numerator from being ridiculously large. Again, proceed in the most convenient way. Bearing in mind that the length of the arc is a fraction of the circumference, if we know the circumference and the fraction, we may multiply them to give the length of the arc. So, the arc is a fraction of the circumference. If we know the circumference and we know the fraction of the circumference that the arcs represent, we may multiply the fraction that is represented by the circumference. So if you can remember, the circles used in finding the circumferences were the same circles used in finding the length of the arcs. If you do not remember, you may rewind the video. But let us multiply the circumferences of the circle by the fractions that the arcs represent. So first one was 22 and 44 and 66, and we are multiplying this by 1/6, and we get the length of the arc. This one 44, we take a quarter, and the result is 11. Next one 66, we take 7/18 and the result is 25.67. So if we had the circumference of the circles before, we just multiply by the fraction of the circumference that the arc represents. Notice that the answers are the same as those obtained in this section on the length of arcs. Where the numbers facilitate, the candidates may find the circumference and the fraction and multiply them. This may be done, for example, but not limited to, situations in which the fraction is a simple one and the radius or diameter is a multiple of 7. So of course, we may take advantage when the diameter or radius is a multiple of 7, because we are going to always have 22/7, and if we're going to have a multiple of 7 to multiply that by, then we know that we can reduce by 7 quite easily. Now, to find the perimeter of an irregular shaped object, simply add all the sides. That is how we find the perimeter of an irregular shaped object. The length of some of the sides are not given, but we are able to calculate them by using the information that is given. So we do not have, like this one here, we don't know, but we can calculate it based on the information that we have already. Say for argument's sake, W, that little portion there, the horizontal distance labeled W is unknown. The entire horizontal dimension of the diagram is W plus 12. So we see we have W come to here, and all the way across there we have 12. See that? So the W and the 12 goes together. That is the distance horizontally. At the upper end of the diagram, the entire horizontal dimension is 9 centimeters plus 7 centimeters. This is because the radius of the quarter circle, or the radius of the circle of which that is a quarter, is equal to 7. So we have here, from here to here is 7. This is the radius of the circle. If this is 7, then this is 7, because the radius has to be 7. So if this part is the radius is 7, this part being the radius also has to be 7. So what do we have? The 7 plus the 9 will be the same thing as the W plus the 12. And of course, we can solve that simple linear equation in order to determine the value of W. And W is equal to 4 centimeters. And we place it right there. We place it small so that we, by taking a look at the diagram, can tell that that 4 centimeter was not a part of the initial setup. So the unknown portion is M. The total vertical dimension is 20, as we have it right there. This is equal to 7 centimeters plus M. So all of this 20, this part goes up to there is M, and we know that this is the radius that goes up some more or completes the distance, which is 7. Therefore, we have the two of them together, and that is equal to 20. So what is the other part equal to? What is equal to that? M is equal to 20 minus 7, because we are just solving that linear equation. So M is equal to 13 centimeters. Any other? Oh, that little short part right there. The unknown portion is L. The total vertical dimension is 20 centimeters. This is equal to 15 centimeters plus L. Like that. How nice. L plus 15 is equal to 20. Simple linear equation also. So we have no problem in solving that one. So L is equal to 5 centimeters, and we put it right there, small, so we know that it is not a part of the original problem. So we are going to find the perimeter now. How do we do that? Add all the sides. So that part, 9 centimeters, then of course 15 centimeters, then of course 12 centimeters, then of course 5 centimeters. Any more? Of course, 4 centimeters all the way around. Notice that we are going around 13 centimeters, and now we are encountering the curved part. So the curved portion is a quarter of the circumference of a circle. And what is the radius of a circle? 7. So a quarter times 2 times pi times r. So a quarter of 2 times 22 over 7 times 7. Of course, that is equal to 11. Of course, we can do a quick check. 7 cancel with 7. 2 times 22 is 44. And 4 into 44 is 11. That's very nice. When we add all of these together, we get 69 centimeters. We have another irregular shaped object. The total vertical dimension, because of course we have some missing sides, like this one is missing. Come all the way around, I think this one is missing. We don't see it well. If we do not see that, we know that it is missing. And of course this portion right here is also missing. We do not know those lengths. So let us see what we can do. Right, so the total vertical dimension is 30 centimeters. The portion that is labeled L is unknown. L is unknown, and the total is 30. Comes across very nicely. So we know that L plus 14 is equal to 30. The solution of this simple linear equation gives L is equal to 16 centimeters, and it goes right there. What else is unknown? The total vertical dimension, of course, we know that is 30, and it is equal to M plus which part? That part there, 10. Right, lovely. So we know that L plus 10 is equal to 30. What number do we add to 10? And the result is 30. Of course, 20. But we can transpose and solve a simple linear equation and put the value where we need to put it. And of course, we have this little portion that we need to calculate. So that is not very difficult. That is unknown. And that is what? 8 plus W, and that is 25. So what do we get? L is equal to 17. No problem solving that simple linear equation. So W plus 8 is equal to 25. So W is equal to 25 minus 8, which is equal to 17. So Richard James Mathematics Resources would have done a lot of linear equation. And the accompanying booklet has over 300 linear equations for the students to practice. 17 centimeters goes right there. And what do we do? Find the perimeter by adding the sides. That side is 25. That one is 20. That one 17. 10 centimeters. 8 centimeters. 16 centimeters. And of course, now we are encountering the curved portion is half of the circumference of a circle. And we know the diameter of the circle is 14. So a half of pi d. So a half of the circumference. So let us work that out. A half times 22 over 7 times 14. Look here. 2 7s 14. So we know that is going to turn out to be 22. Because 14 will cancel with 14. So 22 centimeters. And when we add all of these up, we get the perimeter is equal to 118 lovely centimeters. We are going immediately into area. And the area of a figure is the amount of surface that it covers. And the area of a rectangle is given by, what is it given by? Length multiplied by width. That is your length. That is your width. In algebra, the multiplication sign may be left out, of course. So the area is equal to LW. So we are going to find the area of these rectangles. No problem. Length times width, 3 times 5, 15 centimeters squared. No problem. Why? Recently a student asked me, why centimeters squared? Because the length is centimeters, the width is centimeters. 3 centimeters multiplied by 5 centimeters is going to be what? 3 times 5, 15, and centimeter multiplied by centimeter. So if you multiply something by itself, it is squared. So we have what? 15 centimeters squared. And of course, that's another one, a lovely one. So length multiplied by width, 8 times 12, 96 centimeters squared. Now we are moving merrily on to finding the area of a triangle, and it is given by area is equal to a half times base times height. B is the base, of course, and H is the height. The base must be perpendicular to the height. That is a requirement if you are going to get it right. Without the multiplication sign, the formula may be written as a half BH or BH over 2. For the triangle above, area is equal to a half base times height. So the base is 11 and the height is 8. Of course, you may do a little cancelling, of course, or reducing the fraction. And 2 into 8 is 4. So we have area is 11 times 4, and that is equal to 44 centimeters. Now, notice how this triangle is drawn, where the dimension that represents the height is not within the base of the triangle. But that's okay, as long as wherever we consider to be the base, the height is perpendicular to that, we are okay. A half base times height as usual. So a half, 9 times 14. Of course, no problem seeing how that will be reduced. So area is 9 times 7 is equal to 63 centimeters squared. Triangles continue. Continuing, the last one, I hope. Area is equal to a half times base times height, and the base is 27, the height is 12, and of course we may reduce that. 27 times 6, 2 into 12 is 6. So the area multiplying 27 by 6, we will get 162 centimeters squared. So 6 sevens 42, put down the 2, carry the 4. 6 twos 12 plus 4 is 16, no problem. If we have all of the sides of a triangle, we may find its area by using a particular formula. And that formula looks like more than a mouthful, because it is saying S multiplied by S minus A multiplied by S minus B multiplied by S minus C, and then taking the square root of all of that. What is S? What is A, B, C? Where the value of S is given by A plus B plus C divided by 2. If you are talking about a triangle, well, it makes sense that A, B, and C will be the sides. And it says so right there. A, B, and C are the sides of the triangle. So S is equal to A plus B plus C divided by 2. And of course, if you add all of the sides of a triangle, you will be finding the perimeter. So that is called the semi-perimeter, is equal to half of the perimeter of the triangle. So when using the formula, the value of S must be found first. So the area is what? The square root of all of S times S minus A times S minus B times S minus C. But of course, we need to find S first. S is the semiperimeter, or is found by adding all of the sides of a triangle and dividing the result by 2. So we have now a triangle 6 centimeters, 2.5 centimeters, 6.5 centimeters, and we are going to find the area. So S is equal to add all of the sides, divide the result by 2, and if we do that, we will get 15 to be divided by 2, and that will give 7.5 centimeters. Now S is 7.5, so we're going to have 7.5 minus, say, 6, 7.5 minus 2.5, 7.5 minus 6.5. So we have that 7.5 minus 2.5, so we have 7.5 minus 6, 7.5 minus 6.5. No problem. S is 7.5, found by adding all of the sides and dividing the result by 2. Then we put that value 7.5 right there, and then in the brackets 7.5 minus one side, 7.5 minus the second side, and 7.5 minus the third side. The result will turn out to be this if we simplify, and then eventually we have to find the square root of this. So then what do? 7.5 goes there, then we do the subtraction that we have right there, goes there, then we do the other subtraction, the result goes there, another subtraction, the result goes there. After we have done the subtraction, what do? Multiply this by this by this by this, and the result turns out to be 56.25. Then we find the square root of 56.25, and the area turns out to be 7.5 centimeters squared, and that is just coincidental that it is equal to the semiperimeter right there. And let's hope that we do not have such a clash, so that we cannot draw any conclusion by the fact that the area and the semiperimeter are equal. We have another triangle, sides 7 centimeters, 25 centimeters, 24 centimeters. So we are going to add them and divide the result by 2. When we add them, what do we get? 56? Good. And we divide 56 by 2, we get 28. So what do we do with that 28? 28 minus one side, 28 minus the other, 28 minus the final side. Right. And what do? See, 28 minus 7 minus 25 minus 24. And of course 28 is represented here. So what do? We put the 28 there, then 28 minus 7 is 21, 28 minus 25 is 3, 28 minus 24 is 4. And we multiply all of these together, and after having such a large result, we find the square root, and that is equal to 84 centimeters squared, which is not equal to this. So we have redeemed ourselves. And of course we have another one where we're going to add the sides, 10 plus 6 plus 8 plus 2, dividing the result by 2. That is what we get, 12 centimeters. And of course what? Area is equal to S, S minus A, S minus B, S minus C. So we have 12. 12 minus 10, 12 minus 6, 12 minus 8. Because those are the sides, 10, 6, and 8. So we say 12 goes there. 12 minus 10 is 2. 12 minus 6 is 6. 12 minus 8 is 4. And then we multiply all of these. We get 576. And then we find the square root. That gives 24 centimeters squared, and we move merrily along. of all of the formulae to be used to find the area of a triangle, the one that catches students off guard is A is equal to a half AB sine C. That is the one that we use to establish the sine rule, where A and B are the two sides of a triangle and C is the angle that the two sides form. And of course, for information, we may consult volume 6, trigonometry. So let us move on merely to find the area of circles. The area of a circle is given by, we have two formulae. A is equal to pi r squared when the radius is given, and A is equal to pi d squared over 4 when the diameter is given. And of course, the radius is given by r and the diameter is d. Pi is 22 over 7 or 3.14. Those are the approximations for pi. So A is equal to pi r squared, and of course pi 22 over 7 multiplied by the square of the radius. And of course the radius squared means that we are multiplying the radius by itself, as we have right here. So we are going to do some reduction of fraction, in which we know that 7 divided by 3.5 is 2, because of course 3.5 is half of 7. So we are going to reduce the fraction like that, and of course 22 divided by 2 is equal to 11. So we are going to have 11 to be multiplied by 3.5, and that will give 38.5 centimeters squared. This time the diameter is given, so we are going to use the formula area is equal to pi d squared divided by 4. So here we have pi and the diameter is 14, so 14 squared divided by 4. And of course we are going to simplify. 7 into 14 is 2, so the 7 is gone and we have 2 left right there. And of course we are going to put these two together, so 22 times 2 is 44, and we are going to divide that by 4, and the result is 11. So we'll have 11 to be multiplied by 14 in the end, and that is 154 centimeters squared. We have another one in which the radius is given, so A is equal to pi r squared, 22 over 7, and the radius squared goes there. Of course, square means that we are multiplying the radius by itself, and if we can reduce, 7 into 10.5 is 1.5. So we have 22 to be multiplied by 1.5 to be multiplied by 10.5, and the result is 346.5 centimeters squared. Now we are going to find the area of a sector of a circle, and of course if we can find the fraction of the area that the sector represents, then we can find its area. And of course we are going to go back to our original setup, where the angle associated with one revolution is 360 degrees. So the angle that subtends the sector is theta. So the fraction of the area of the circle that the sector represents is given by theta over 360, and that is our fraction. So what do we do? Remember that the formula for the area of the circle is area is equal to pi r squared, or may use A is equal to pi d squared over 4. The area of the sector is therefore given by the fraction of the area of the circle represented by the sector, which is this, multiplied by the area of the circle, which is this. So theta over 360 multiplied by pi r squared. In the event that the diameter is given, we may use what? Pi d squared over 4. So we're going to find the area of the sector specified by the given angle, and the angle that is given in this particular case is 60 degrees. So 60 degrees over 360 degrees to be multiplied by 22 over 7 times what? The radius? Times the radius, 3.5 centimeters. Right. And of course, when we square, we multiply the 3.5 by itself, and we are going to do our reduction. So we are reducing these, and we are reducing these. And of course, we know that 3.5 is a half of 7. So 3.5 into 7 is 2. So we have 360 divided by 60 is 6. And 7 divided by 3.5 is 2. So this will give 1/6 like we have right there. And this will give a 2 right there, because 3.5 will go into 7 2 times. And of course, that is what we have left. Anything else to be reduced? Yes. 2 into 22. So we have 11 multiplied by, so we have 2 into 22 is 11. 11 multiplied by 35 to be divided by 6. And that's what we have right there. And the result is 6.42 centimeters squared. So here we have another one, but this time the diameter of the circle is given, and the angle, there's no figure, no number representing the angle, but we know that any angle that is marked with right angles like this has to be a 90 degrees angle or a right angle. So no problem seeing that 90 over 360 times 22 over 7, that is pi, and d squared over 4. 14 squared, the diameter is 14, diameter squared over 4. So we are going to be reducing again. This time 360 divided by 90 is 4. So, and 7 into 14 is 2. So we are going to have this goes to 4, and 7 into 14 is 2. So we have 1/4. And then we have 22 times 2 times 14 over 4. And of course, there's no doubt that we can reduce again. 2 times 22 is 44. And 44 divided by 4 is 11. So this is 44. 2 times 22 is 44. And we are going to reduce that with 4. So we are going to have 11 times 14 over 2. We are continuing our reduction. So we have what? 4 here, 14, 2 into 4 is 2, and 2 into 14 is 7. And it reduces quite significantly. So we just have 7 times 11 is 77 to be divided by 2, and we get 38.5 centimeters squared. Of course, we have another one, but this time the radius is given, and we are going to use theta to be divided by 360 times pi r squared. And we are just going to put the figures in, and of course we have 10.5 squared means 10.5 multiplied by 10.5, and we are going to reduce those two by saying what? 20 into this and 20 into that, and then reduce this. Of course, we know that 7 will go into 10.5 1.5 times. So let's see what we have. 7 over 18 times 22 times 1.5 times 10.5. And of course, we may do some further reduction by saying what can go into 18? 18 to be divided by 3 is 6 times. And 1.5 divided by 3 is 0.5. Right. Of course, we have other reductions, but we are just going to opt to multiply the numerators and then divide by 6. And the answer is 134.75 centimeters squared. Now we're going to look at the area of a trapezium. A trapezium is a quadrilateral with at least one pair of parallel sides. The area of a trapezium is given by, we have it like this, b over 2 h1 plus h2. Now, depending on the region of this world that we are taking information from, a trapezium, say for argument's sake, in country A is different from a trapezium in country B only in the way that we name the sides. So then, it is the only difference is the way that we name the sides. Now, if we can always identify the sides that we are talking about, then we have no problem whatsoever working with trapezium. So, H1 and H2, we're not going to say height or base. We're going to say H1 and H2 are the two parallel sides. Irrespective of the country that we are taking our dictates from, the formula is always going to be the same if we consider the two numbers that we are adding inside the bracket, H1 and H2, to be the two parallel sides. And B will be the perpendicular distance between the two parallel sides. So it is not a matter of what is base and what is the height 1 and what is the height 2. It is a matter of, if we have a formula like this, whatever we have here, if it is even x, we know that the one that we have here dividing by 2 is going to be the perpendicular distance between the parallel sides. And we know if we have P here and W here, these two are going to always represent the two parallel sides. So for the first one, we have the area is equal to B over 2 H1 plus H2. So the perpendicular distance between the two parallel sides will go here, and H1 and H2 are the two parallel sides. These are the two parallel sides, and if we cannot identify them, we are identifying them there. Right. And of course, B is the perpendicular distance between the two parallel sides, and it goes right there. So all we have to do is substitute the two parallel sides right here, and the perpendicular distance between the two parallel sides will go right there. And when we simplify, we just say 14 plus 17 and 12 divided by 2, and 12 to be divided by 2 is 6. So 6 times 31, and the area is equal to 186 centimeters squared. Here we have another one. There's our formula. It does not matter what these two symbols look like. H1, H2, P1, P2, X and W are W and T. It does not matter. The two parallel sides, that's what H1 and H2 are. And those are the two parallel sides. And B, not base, distance between the two parallel sides. Always the perpendicular distance between the two parallel sides. Therefore, B will be replaced by 10, and H1 and H2 are 14 and 18 respectively. So we say 14 plus 18 is 32, and 10 to the B divided by 2, we cancel or reduce the fraction, and we get 10 times 16, and that is equal to 160 centimeters squared. And there we have another one. What do? Use the formula just as before. What are the two numbers that go inside the bracket? The two parallel sides. And the perpendicular distance between the two parallel sides is the one that goes right there. So 10 over 2, 17 plus 21. So we have 17 plus 21 is 38. 10 over 2, and of course we can do a little reduction. 2 into 38 is 19. So 10 multiplied by 19 is 190 centimeters squared. And the area of a trapezium will play a very important role, especially when we move on to a particular topic in functions, relations, and graph. Distance and velocity time graphs. Especially the velocity time graphs, they like to put a trapezium somewhere inside of that problem for you to find the area of it. And if we are skillful at identifying the perpendicular distance between the two parallel sides and the parallel sides, then we'll have no problem finding the area of those trapezia. So, more area, the curved surface area, that is what we're looking at. And we're looking at the curved surface area of a cone. and the curved surface area of a cone is given by A is equal to 2/3 pi RH if the radius of the base is given, and A is equal to 1/3 pi DH if the diameter of the base is given. Of course, we know R is the radius of the base of the cone, D is the diameter of the base of the cone, and H is the height of the cone, where H must be perpendicular to the circular base of the cone. So A is equal to 2/3 pi RH because we have the radius right here. So pi is 22/7, R is 10, and the height is 14, and that's all there is to it. Of course, we can reduce right there, and we get 14 to be divided by 7 is equal to 2. Right. And of course, we multiply all the numerators, and that will be placed over 3. 3 being the only denominator. So the area is equal to 293.3 centimeters squared. There's another cone. And why do we use area is equal to 1/3 pi dh? Why do we use that? Because the diameter of the base is given in this particular case. So 1/3 pi diameter h, 1/3 pi dh. And of course, some simplification, right? And 7 into 10.5 is 1.5. So what do we have? 22 times 1.5 times 8. We have 264 centimeters squared. The area of the curved surface of a cone is given by area is equal to 2/3 pi RH, or area is equal to 1/3 pi DH. And no problem, we have the radius, so let us use the one that pertains to radius. And we have 2/3 pi, the radius of the base, and the height. And of course, that is easy. 3 7s 21, and 21 into 21 will cancel each other very nicely. And we have area is equal to 2 times 22 times 5. So 220 centimeters squared, and that is the area of the curved surface of the cone. We have other curved surfaces, but this time the curved surface of a cylinder. And the area of a curved surface of a cylinder is given by area is equal to 2 pi RH, or area is equal to pi dH. So we have the radius of the first one, so area is equal to 2 pi RH. So area is equal to 2 times 22/7 times 10 times 14. No problem. 7 into 14 is 2. So we have a very nice and simple problem right here. So we have 2 times 22 times 10 times 2. By looking at the 3 occurrences of 2 in the multiplication, we know we are looking at 880 centimeters squared. For this one, the area of the curved surface, and we have the 2 formulae, and which one are we going to use? The one that pertains to the diameter, because the diameter is given right there. Right. So we have 22/7 times 10.5 times 24. That cancel, of course, we know that 7 into 10.5 is 1.5. And we have 22 times 1.5 times 24, and that turns out to be 792 centimeters squared. The area of the curved surface of a cylinder, as usual, and of course, for this one, the radius of the base is given. So A is equal to 2 pi RH. Two times 22/7, that's pi. The radius is 5, and the height is 21, and this simplifies quite easily. 7 into 21 is 3. So we have 2 times 22 times 5 times 3. Of course, we know that 3 times 22 is 66 and 2 times 5 is 10. So we have 660 centimeters squared. And of course, we have irregular shapes, and we are going to find the area of the irregular shape figure. And in order to do that, because it is irregularly shaped, we are going to divide this figure into areas of which we know the formulae. So, how do we do that? So the first section that we are going to divide that into is a rectangle that is 4 centimeters by 5 centimeters. So 4 by 5, that one right there, 4 by 5. Then we have another rectangle, 8 by 16. Of course, we know that this is 9 centimeters. Here we have the radius, which is 7, so this has to be 7 if this is the radius. So we have 7 and we have 9 here. So all the distance here is equal to 16 centimeters. And how do we determine that this region is going to be 8 centimeters? Because this portion is 7 and the entire thing is 15. So we are sure that this region is 15 minus 7, which is equal to 8 centimeters. So this is 8 centimeters by 16 centimeters. And we have another rectangle. This one is not difficult for us to see though. This one is 7 by 9. Okay? And after that, we need to find the area of a quarter of a circle. And of course, it's just a quarter of pi r squared. That is the area of a circle. Pi r squared. The radius is given in this particular case. So let us see what we do with it. So a quarter times 22 over 7 times 7 squared. And of course, 7 will cancel with 7 and 4 into 22. So we will have 11 times 7 to be divided by 2. And that will give 38.5 centimeters. Of course, we need to do our little arithmetic here. 4 times 5 is 20. 8 times 16, 128. 9 times 7, 63 to be added to 38.5. And the final result is 249.5 centimeters squared. We're going to divide this one also into manageable shapes. We have a rectangle that is right here, 10 by 8. So it is 10 by 8 or 8 by 10. That's what it is. And that is the rectangle that we have right there. Now we have another rectangle, which is this big one. So no problem with that. What do we say that one is? That one is 20 by 25. Right? So that's the one. 20 by 25. And of course, what is this? A half of a circle. And the diameter of that circle is 14 centimeters. So we're going to find a half of area for the circle when the diameter is given. And if we simplify, of course, we're going to say 14 squared is 14 times 14, and then we simplify very quickly. 7 into 14 is 2, and 2 into 14 is 7. And then, any more simplification? Yes, this with this. So we have another step to simplify. Yes, finally. 11 times 7, that is 77 centimeters squared. Then we add all of them together. The 77 to be added to 20 times 25 and also to 8 times 10. And the result is 657 centimeters squared. Now we have volumes. And the first figure that we're going to be looking at is a pyramid. What is a pyramid? A pyramid is a three-dimensional figure with a base and whose other sides have a common vertex. Its volume is given by V is equal to 1/3 AH. What does that mean? A is the area of the base and H is the height. So the height is required to be, as usual, perpendicular to the base. A pyramid is given name according to the shape of its base. So if the base is triangular, then the pyramid is called a triangular pyramid. If the base is a rectangle, it is called a rectangular pyramid. And if the base is circular, it is called a circular pyramid that we know to be called a cone. Find the volume of the pyramid. What is the volume of the pyramid given by? Well, let us look at what this information is telling us first before we jump. Jumping to conclusion is bad exercise. The base of the pyramid is in the shape of a right-angled triangle. The area of the base may be easily found because of the two perpendicular lines. So of course this is perpendicular to this and we have a triangular base, right? So we can find the area of this triangle by using half base times height. Why? Because the base is perpendicular to the height, or the height is required to be perpendicular to the base in a triangle. So because these lines are perpendicular, we have half of our work finished already. So volume is equal to 1/3 the area of the base times the height. And the area of the base is in the shape of a triangle, and the area of a triangle is half base times height. So we have 1/3 the area of the base times the height. Of course we are using two different h's. H, the capital or the uppercase H, is pertaining to the height of the entire pyramid, and the lowercase h is pertaining to the height of the triangular base, or the height of a triangle which represents the base. So having all of this, 1/3 the area of the base is a half base times height, and then we multiply that by the entire height of the pyramid, h, uppercase H. Right. So we have simplifications, and then we have what? 2 times 9 is equal to 18 centimeters cubed, or cubic centimeters. In the solution, the height of the pyramid was symbolized by the uppercase H in order to accommodate the height, which is the lowercase h, of the triangular base of the pyramid. Continuing, the volume is what? The base of the pyramid is in the shape of a rectangle whose area is given by, what is the area of a rectangle? Length multiplied by width. 1/3 the area of the base times the height. So what is the area of the base? In the shape of a rectangle, the area of a rectangle is length times width and then times the height. So it is 1/3 the length times the width times the height. So we have here 5 times 6, and that represents the area of the base of the pyramid. And of course we have the height right there, and we are using this 1/3 that is a part of the formula. And of course we write it more conveniently, and then we reduce. So we have V, the volume is 80 centimeters cubed, or cubic centimeters. So here we have another one. The base of the pyramid is a circle. The diameter of the circle is given, so let us use a formula that has diameter. So that is what we're going to use. A third the area of the base times height as usual. Remember, the volume of the pyramid is 1/3 the area of the base multiplied by the height all the time. And of course, the area is found different ways because of the different shape of the bases. And of course, we are substituting the values. 1/3 pi is 22/7, d is 8, so 8 squared, and of course over 4 goes right there. The height of the pyramid is 10.5 centimeters, goes right there. And of course we're going to write that more manageable, so we can simplify quite easily. 4 into 8, and of course this 3 times 7 is 21, and 21 will cancel with 10.5. Of course 10.5 is half of 21, so when we say 10.5 into 21, which is 3 times 7, we will get 2. So we have 2 here. This 2 from the 10.5 into the 21, which is the 3 times 7, we get 2. The 4 is gone completely with the 8 to give 2. And of course we may just simplify, and V is equal to 22 times 8, which is 176 centimeters cube, or cubic centimeters. V is equal to 1/3 AH, 1/3 the area of the base times height, may be used to derive a standard formula for the volume of a cone. So we have 1/3 the area of the base times height. What is the area of the base? A circle. So because the base is a circle, we have pi r squared, and then that turns out to be 1/3 pi r squared h, and that's a standard formula for the volume of a cone. Or if we want to use the one that makes use of the diameter, we can proceed the same way. Pi d squared over 4 is the area, and then when we simplify we have 3 4 is 12, so it is 1/12 pi d squared h, 1/12 pi d squared h, and those are standard formulae that may be used to determine the volume of a cone. We will move merrily on to prisms. A prism is a three-dimensional figure with a uniform cross-section. Its volume is given by, very simple, A times L, and of course A is the area of the cross-section and L is the length. The length is required to be perpendicular to the cross-section. A prism is given name according to the shape of its cross-section. So here we have a rectangular prism because of course it is of rectangular cross-section, and this is a circular prism which is called a cylinder, and it of course has a circular cross-section, and this one is called a triangular prism because of its triangular cross-section. So let us look at what the cross-section really means. The cross-section is the shape of each slice if we cut the figure into slices of equal size throughout its length. So if we go throughout the length, dividing or cutting it into slices of equal size, then we understand that the shape of each slice is going to be the cross-section. So the cross-section, equal rectangular slices in this particular case, so we know that the cross-section is that shape that we have there that began at one extreme and will end at the other. So we know that is our rectangular cross-section, and of course this cross-section that we have there is going to be triangular in shape, and of course if we put the slices there, we have a triangle that we can translate throughout the entire length of the figure, and that triangle will not change in size. So right throughout the triangle is actually the same size, so we know that that triangle represents the cross-section of that shape. And of course, what about this one, circular cross-section? Throughout if we keep cutting it into slices, the slices will be circular in shape, and that is going to be throughout, and all of those slices will be of the same size. And that is how we can identify the cross section. The slices of equal size that we can cut throughout the entire length of the prism. So let us find the volume. Find the volume. The volume is found by what? Simple formula. A times L. What is A? The cross-sectional area. What is the length? So then, the cross-section is in the shape of a right-angled triangle. So we have a half base times height for the area of the triangle to be multiplied by the length. Of course, because it is right-angled triangle, we know that if we call this the base, and this is the height is perpendicular to the base, so we have no drawbacks right there. We may just go merrily along. So we have values are substituted. The base, we are going to use that for 5, and the height 12. We can use the 12 as the base and the 5 as the height, as long as the base and the height are perpendicular. So no problem with that whatsoever. And of course, we may proceed to simplify. So we have 5 times 12 times 20. So 5 times 12 is 60 times 20, 1,200 centimeters cube or cubic centimeters. And we need to find the volume of that one also, and the cross section is in the shape of a rectangle. No problem with that one. If a rectangle is length times width. So there we have it. So what do we say then? Just multiply this 7 by 4 times 3, and we get 840 centimeters cube. The volume, which is equal to area times length, may be used to derive standard formulae for the volume of a rectangular prism. So let us look at that. V is equal to AL. What is the area in the shape of a rectangle, which is length times width? So V is equal to length times width times height. Of course, we have it right here, but not in such explicit arrangement, with the multiplication signs shown. And of course, the volume of that one, same way. V is equal to AL, but the area is in the shape of a circle whose diameter is given. So V is equal to pi d squared over 4 times L. And when we are done with that one, we simplify as usual. 4 into 24 and 7 into 10.5 is 1.5. Do not forget that. So we have here 2 times 1.5 times 10.5 times 6. That's what we're going to have. 22 times 1.5, that is 7 into 10.5 is 1.5. So 22 times 1.5 times 10.5, and then 4 into 24 is 6. Right. And we have 2,079 centimeters cubed. V is equal to AL may be used to derive standard formulae for the volume. So we have the area, pi r squared times length, and then that turns out to be pi r squared L. So V is equal to pi r squared L. That is the formula for the volume of a cylinder that we know to be a circular prism. And of course, we may use the other one that makes use of the diameter, pi d squared over 4 times L. So we have volume is equal to a quarter pi d squared L. Very good. So the total surface area, that's what we're going to look at now, because that's what is usually required, sometimes required in our examinations. Some problems may require the total surface area of a solid. Since we know how to determine the area of all of the sides, all we need to do is to find the sum of them. Well, if we can find the area of all the sides, we just add the areas, and then we'll find the total surface area. So, of course, what do we have at both ends, as we have indicated right there? we have, at the end, we have two of the triangles that represent the cross-sectional area. So we have to find the area of these two triangles. So we say 2 times the area of one of them. So 2 times a half times 5 times 12. So that's the two ends there. Then we have the rectangle that is above, which is 5 by 40. So that is 5 by 40. That's a rectangle. And do we have another rectangle? Of course. We have one here at the back, 12 by 40. So we have 12 by 40 right there. So it goes right there also. And if we have any other, yes we do. Right. So at the front we have rectangle 13 by 40. And what is that? How did we get the 13? Well, we will show how we arrived at the 13 on the next slide. So we have what? We are sure that is 13 by 40. And that goes right there. And when we simplify, what do we get? We have this 2 to cancel with the half completely. So 5, 12, 60. 5 times 4 is 20. So 5 times 40 is 200. Then we have 12, 4 is 48. So 12 times 40 is 480. And of course, 13 times 4 is 52. So 13 times 40 is 520. So in all, we have a total surface area of 1,260 centimeters squared. And we are going to see how we find the length of the missing side. So let us enlarge the triangular cross section just to take a closer look at it. So it is a right angle triangle whose hypotenuse is not known. So let us use Pythagoras theorem to find it. So here is a part of trigonometry coming into play right there. So consult, of course, volume number 6, working with right angle triangle. That is topic number 32. And we have no problem seeing that Pythagoras theorem will work very nicely right there. So h is equal to the square root of 5 squared plus 12 squared, which is the hypotenuse, is equal to, and 25. So 5 squared is 25. 12 squared is 144. When we add these, we get 169. So actually, the hypotenuse is 13. So this part is 13. So that is how we arrive at our 13 for the front to be 13 by 40. We are continuing with total surface area, and this is an easy one. The rectangular prism, which is the cuboid, may be one of the simplest solid for which we may be required to find the total surface area. This is because opposite faces are equal. We therefore have 3 pairs of faces. So that's one pair. So it is going to be what? That pair, and the dimension is what? 7 by 4. But there are 2 of them, so it is 2 7 by 4. That pair, the second pair, has dimensions 30 by 4. So 30, we can take it from here, because we know that all of this will be 30. 30 by 4. So 2, we have 2 of them, so 2 30 by 4. And of course, this at the front and the one at the back, this is 7 here and 30 up there, so we know 2 30 by 7. So we have 56 plus 240 plus 420, so we have 716 centimeters squared. The total surface area continues. and we are finding the total surface area of a circular prism, which of course is a cylinder. So the circular prism has two circular faces, one at each end. The total area will have two identical circles. The only other surface is the curved one. So we have the two circles at the ends. So let us include those areas in our total surface area. So 2 times the area of the circle, and of course we are using pi d squared over 4 because the diameter is given. The curved surface area is next. So remember that the curved surface area is what? Pi d h r 2 pi r h is either 2 pi r h or pi d h, but we are making use of the diameter that we have right there. So 22 over 7 times d times h. Okay, and when we simplify, this is our result: 965.25 centimeters squared. Sometimes it is required that we find the total surface area of a hollow cylinder that is open at one end. In this event, the area of the circle is included only once. So if it is opened at one end, we are going to make use of the end that is closed, because one of the circles will be missing. Students should now be equipped with the basic knowledge of mensuration. However, the skills required do not end here, as we all need to be equipped with common sense and the other areas of geometry that are sometimes incorporated in problems. It is not uncommon to merge this topic with algebra, resulting in problems that have some high-power algebraic expression that turn out to be quadratic or to be simultaneous equations on some occasions. There is really no need to worry, as Richard James Mathematics Resources has covered the meats and potatoes of the theoretical requirements of the CSEC syllabus. It might excite prospective examination candidates that after this present volume, I will move on to another phase of work that will cause them to run and leap with joy like a gazelle. No hint as yet, just keep on watching. In addition to the instructional material, students will be completely prepared for examinations.